Welcome to the PTV Viswalk webinar on the Viswalk and public transport functionality. I will do this webinar more in the style of a tutorial or the first steps in a training course. So I will go through the functionality in a rather simple demo model, and you might even want to click along while I demonstrate if you have a separate PC available. So let's begin. The first thing I need is a link on which later the public transport vehicle is meant to drive. So here we are, and I want to have it about 300 meters long, so that's here, and yeah, that's it. So let's go here, and then I want to create a public transport stop, pardon. So the public transport stop is created public transport stop mode, obviously, and again with control right click I can create a public transport stop. It should be 45 meters long, and here we are. We get the context menu, and I can create a platform edge on the right side. And that platform edge, it's a pedestrian area which serves as a platform edge. But before we now add further pedestrian infrastructure, I want to insert and add a public transport line such that we have the public transport service in the model with control right click and another control right click. There we have the line, and the first line should be a train. It should go at about 50 kilometers per hour, and I want it to run at a high frequency of 120 seconds throughout the simulation, so for 1 hour. And on each train, when it is set into the simulation, there should be 20 passengers on board. So here we are, you see the services have been created here, each 120 seconds, with 20 passengers on board when the train is set into the simulation. Okay. Now, let's take care and add the pedestrian infrastructure, which you see here with the yellow marked icons. And we need first an area which covers the platform as such. So that's really where there is the concrete of the platform, and all of the default settings are fine for that one. And we need a kind of an entrance to that platform in a real model. That would be often stairs coming from some other level, from a concourse or an overpass, and yeah, so we need that here. So pedestrians alighting from the train, they will walk here if we add a route. So here we are in pedestrian routes mode, and I insert a route from the platform edge area to the exit and entrance area of the platform. Normally, a route has to start exactly there where a pedestrian is set into the simulation. But the drain where the pedestrians later will be set into the simulation, it doesn't exist at the moment when we're modeling, so we need a different solution. And the different solution is that at the very first spot or very first moment where pedestrians really enter an area in the world of pedestrian, in the infrastructure of pedestrians, there has to be the route decision, and this first spot is the platform edge. And that's the purpose of platform edge areas, that they hold route decisions for pedestrians alighting from a train. Yeah, so that's it, what we need as a very, very basic model to see pedestrians stepping out of a train, and we can run the simulation. So here it is, and you see that they are created inside the train, and then they walk out and go to the destination which we have created. We can also watch this in 3D. So you can see the time here, and now we have 2 minutes, and the second train is approaching, and it stops, the doors are opening, and the pedestrians walk to the exit area. So back to editing mode. The next thing I will show is that, 20 pedestrians were set, are on a train when the train is set into the simulation. And maybe not necessarily in a model you want that all of these pedestrians alight already at the first stop, and to define that number, which percentage, which ratio of pedestrians who are on a train should alight, you have to go to the public transport line mode, then select a line, typically in the list of public transport lines, and double left click on a stop, and you get the PT line stop dialog. And here is the percentage number, and let's just go to 25%. So we expect now that of these 20 pedestrians who are on board, 5 will alight. And you could also set here, change the alighting composition. So just as in the pedestrian only usage mode of PTV Viswalk, you can choose between different compositions at an input. You can use the very same compositions for pedestrians alighting from a train. But I won't change that now, I just mentioned it here. Okay. So let's go. Here they are, 1, 2, 3, 4, 5. That's it. Stop, and let's set that back again to 100%, as later it's more interesting to have 20 pedestrians stepping out of the train. Maybe your platform has more than one exit, and you might want that pedestrians alighting from the rear of the train rather head for the exit which is close to them, and also the pedestrians alighting from the front of the train, that they also exit more to the exit area which is close to them when they step out of the train. And that's what I will do in the next few modeling steps. So I first create another exit area here, so that's just doubled, and I will also double the platform edge area with a right click and then just duplicate here, and I can reduce the size of the newly created area and also reduce the size of the original area. We can check that in the wireframe mode. So that's now actually really two areas, although in the solid mode it looks like just one. You see that here. And I need to verify that this is still used for public transport stop number 1, the new area. And now I can create the route for this new platform edge area here. So control right to create a route decision, then a route and a second route, and also the first original route decision now should have a second route to the new exit area here. And to set the route choice probabilities, the relative flows, we can go to the list of routes, which is here, and or the list of route decisions, and show for each route decision here the list of routes which start at the route decision. So that's our route number 1. You see the red dot is a bit larger here now and marks that this is active, and so we want those alighting from the front to also go more to the front exit, and those alighting from the rear end that they should rather go to the rear end. So now I have configured that it's a 90% 10% choice of the passengers. These relative flows of the routes, they are probabilities for each individual pedestrian. So you cannot expect that really always from 10 pedestrians now 9 will go the second route here and 1 will go the first route, but it can also be a 2 to 8 or a 0 to 10 ratio. That is just different from each time, in this case when a train arrives. So far, the pedestrians have been alighting more or less with equal probability and the same number about at each of the doors. We can imagine that maybe this exit is more attractive when we know that passengers in public transport, they already board to a train such that at their final destination they are closer to the exit which they really want to leave the train, and that can be modeled as well. And first that we really can see that I want to have more passengers alighting from the train, and so I go again to the public transport lines mode and I select the line, and I change in the departure times how many pedestrians are on board, equals times 5, and we will have 100 on each train when it is set into the simulation. And now at the line stop data, we can change the alighting location here, and I want to have a majority alighting at the rear end. Here we go. And you see that in fact at the front it's already finished, and at the rear end there is still pedestrians alighting. So that's exactly what we intended to do, and that these keywords, front, rear, center, rear and front, these are not keywords with an internally fixed number, but you can edit these spatial or location distributions and just create your own. So our back or rear distribution looks like that. So not so many at the front. So it's the incline is rather small for the small numbers of location positions, and at the rear end it's steeper, and that means more will alight to the rear. Okay, so far we've only had alighting passengers. That's quite simple. The next thing is that we also want to have, of course, boarding passengers, but for that I will first set back the distribution here to no distribution, which means it's about equal, and I will also go back to fewer pedestrians, alighting. That was a bit too much. Okay. So if we want to have boarding pedestrians, of course, we first need an input where the pedestrians are set into the simulation. So we need to go to inputs mode, control right click, and then see what it looks like in the list. It's just one entry, a number on an area, and we need a volume. Let's have here 600 pedestrians per hour, which means that it's about 20 pedestrians within 2 minutes. So we'll expect that about 20 pedestrians will be boarding per train. To make these pedestrians really wait for a public transport vehicle, we need one additional area, and that area needs, as a public transport usage, it needs the flag waiting area, and then of course for stop number 1. Okay, and with this flag and the information for which stop it is set, pedestrians which we send to that area by a route, they will not be taken out of the simulation once they reach the area, but they will wait there for a public transport vehicle to arrive. So let's see how that looks like in the simulation. So there are some. They've missed just the first train, so they have to wait for the second. So the boarding passengers, they let the alighting passengers alight from the train. And then they start boarding. And when there is no more passenger approaching the train, then the train departs. But what happens if we have a higher flow of passengers willing to board approaching? So that's now quite many. And we can expect maybe that will not stop, and the driver has no chance really to depart if he has the rule only depart if no more are approaching. So there is always a queue, and they always want to hop on the train, and there's a second train coming. Oh, now it's leaving. So what was the reason for that? Now the reason was, we can check that here in the list of vehicles in network. when I add the information on occupancy to this list as a column, and you see the number is rising. So when by and by pedestrians are boarding the train, the number is growing. So it's really kept book of how many pedestrians are there on board. And here it's now with 216, it's departing. And what's the reason for that? The reason for that is we can see that in the list of vehicle types that the tram has a capacity of 215 passengers. So even if the rule for the driver in the simulation is as long as still boarding passengers are approaching, stay standing, don't depart, once capacity is reached, the train will depart. Obviously, that's not everywhere the rule like this. Usually, we have a timetable, and the timetable can be modeled as well. So that's the next thing we want to do. And for that, I need to go to public transport lines mode again. And in the list of lines, I select our one single line, double click on the stop area, and here I can define a departure time offset, let's say of 90 seconds. That doesn't mean that the train will leave exactly at simulation time 90 seconds, but it means it will leave exactly 90 seconds after it has been set into the simulation, which is the only thing that makes sense here. And let's see what that now implies for the simulation. Here we are. So it was set into the simulation at 0 seconds, and we just watch here time passing by, and at about 90 seconds, 1 minute 30, it will depart. Although here, as you see here, capacity is not reached with occupancy. Sorry, it does not leave. I need to do one more thing. This train, it has a timetable, but it's still active that the driver should wait for pedestrians who are willing to board and who are late. And I need to tell the driver, don't wait for them. And then it happens, as I said. So we are approaching, we are reaching 1 minute 30, and the train departs exactly on time, although the occupancy was just at less than 100 passengers. Another mode to control departure of the vehicle is if you don't use a departure time offset, but if you tell the train that it should stand in the station for a certain time, minimum dwell time. Minimum means if there is no passenger willing to board, no one on the stop at all, then it will definitely stay here for 60 plus minus 2 seconds in this case of this time distribution. While when there is many pedestrians and late boarding possible is not checked here, then it will stay standing here for a maximum of that time. So then the minimum dwell time also is a maximum dwell time, but still it says here minimum. So there is a relation between these two as well. And let's see, so we now need to be aware at which time does the train stop. That's about at 20 seconds. So we expect that at the simulation time of 1 minute and 20 seconds, it will probably leave. And so it does. So for the next steps, let's reduce the number of boarding passengers a little bit, that it's not so many. So it's now 2,500 per hour. What I've shown you before for the alighting passengers, that they can leave the train predominantly at the rear end or at the front end. You can also do that for the boarding passengers, so that they board the train more to the back end, more to the front, and for that you have to open the dialog of areas. You can also add it in the list of areas. What you need to do is just at the public transport usage data change to, for example, back or rear end distribution, and then the boarding passengers will head mainly for the rear end. That's something you can do, for example, when the passengers have reservations, and you know at that stop typically there is more people who have reservations to the rear end of the train or to the front end, and then they will go to that end or to that position which you have defined. So far we've just had one public transport line at this stop. Usually there is more than one line at a stop, and that's what I want to do now, create a second line. Let me first reduce here to 1200, and I want to introduce here now not a second drum line, but just to distinguish the two better, a bus line. Here we are. So bus, that's fine. Also 50 kilometers per hour. And the departure times should be just in the gaps in the middle of the arrivals of the tram. And as it's a bus, let's have not 20 but 5 passengers on board. Okay. Here we are, so that's the bus services, and now we see the passengers also utilizing a bus. That's still not fully realistic in the sense that normally at a normal stop, not all passengers waiting for a train or a bus will hop on the first one to come. Some will wait still for the bus, although the tram is there. Some will wait for the tram, although the bus is there. Well, that can be modeled as well. We need to go to the public transport stops mode, double-click on the stop, and the dialog opens for the public transport stop data. Then go to boarding passengers, and add here, select here that there should be, or there needs to be a line for the first public transport line, and we need to have a line for the second public transport line. So number 1 is our tram, number 2 is our bus, and we want maybe twice as many going to the tram than to the bus. So that's what this configuration here says. And if we now run the simulation, we see exactly that some passengers stay standing, for example this guy here. Although the tram has arrived, he will wait for the bus. And some of those approaching now, having arrived now, they will stay standing here waiting for the drum. Now, one final thing maybe you have realized and wondered, the doors of the drum, they are really shown, they are animated, they open when the drum approaches. That's a matter of the 3D model. So the model, a 3D model of the drum, it really has those doors opening defined. While the bus, the doors are not shown opening. Nevertheless, the pedestrians could hop on the bus. They just were shown walking through a closed door, so that's something where you have to imagine something then. Just in case the buses in your city have a slightly different design, different geometry, you can override the position of the doors, especially in those models where doors are not shown opening and closing. And to do so, you need to open the list of 2D, 3D model segments. And then here select the bus, and as a secondary list, select the list of doors. And let me here just delete one of the doors and set the other one, place the other one really at the rear end. So now we will see a difference where the pedestrians are going to board the bus. Before, they have really been going to the position where the doors are shown, and now they will go to the rear end where there is not really a door shown displayed. But if the buses in your public transport system have a door at the very end or somewhere else, you just can model that such that this also is modeled correctly in accordance to reality. Good, that's it. That's what I wanted to show to you in half an hour. So that fitted well. If you now have questions in the chat, you can ask them, or you can also send in a mail, and we will reply to the questions later on. So thank you. That's it.